answering number 4 here, glycolysis has 3 different phases to it: energy investment phase, splitting phase, oxidizing / reducing phase. In the energy investment phase, you're putting 2 ATP in order to change glucose into glucose 6-phosphate. This uses the enzyme hexokinase in order to convert it over to glucose 6-phosphate. Since you are putting 2 ATP in, you are already down 2 ATP in glycolysis. So whatever the amount, it is 4, but it will be 4 minus 2 is why we get the net of 2 ATP. The main goal of this is to convert glucose into glucose 6-phosphate and then glucose or fructose 6-phosphate afterwards. Next is the splitting phase. In the splitting phase, the goal is to change that 6-carbon molecule into 2 3-carbon molecules or pyruvates. The reason that we want to do this is because pyruvates can follow 3 different pathways after they are converted into pyruvates. It can go into acetyl-CoA for glycolysis. It can go into lactate, which will be able to resynthesize 15 ATP, and then it goes into another pathway which doesn't quite intertwine into glycolysis, so I won't be speaking on it. In the splitting phase, that fructose 6-phosphate will be turned into fructose 1,6-biphosphate, which is then put into the 2 3-carbon molecules of G3P and DHAP. These 2 molecules are isomerases, which means that they are going to rearrange the molecule around. As a result, 2 molecules of G3P are going to be produced. Each will proceed through the next phase of glycolysis, which will be used in order to generate energy. The final part of glycolysis is the oxidizing and reducing phase. In the oxidizing and reducing phase, G3P is getting oxidized, which means it does lose its electrons. The oxidation converts G3P into 1,3-G3P or BPG, 1,3-BPG biphosphate. All the electrons are then being transferred to NAD+, making NADH. This is how you get the NADH part. This phase, again, creates NADH and prepares the molecule for the next step where ATP is being generated. The main goal of this is to resynthesize 4 ATP. The reason we get a 2 net ATP is because we did have the energy investment phase, which we already are starting minus 2 ATP, 4 minus 2, 2 ATP. So in the oxidation and reduction phase, we are making 4 ATP, but getting a net of 2 ATP through glycolysis in total. There are 3 different enzymes used in glycolysis in order to create the system or process of it. One of those is isomerases. So isomerases they're called mutases. Basically, they mutate or rearrange the molecule. So nothing is being added, nothing is being taken away. It's just rearranging how the molecule is structured, and this will change how the molecule acts and what the molecule does and how quickly it does things. But basically, this is just rearranging molecules for the better of the body. Dehydrogenases. Dehydrogenases are enzymes that remove electrons from molecules, and then they pass them on to carriers. Dehydrogenases will help produce energy-rich molecules, which often then lead to the cell creating energy. Dehydrogenases are exactly what they sound like. Oxidizing and reducing things doesn't exactly mean hydrogen, but it is oxidizing and reducing. And then finally are kinases. Now, kinases are enzymes that transfer groups. Kinases are known as transferases, and the main goal of a transferase or a kinase is to move one substrate to another. So it's moving something across a gradient or across, say, like a cycle. It is making sure to speed up that process of bringing something over. 3 most influential enzymes in glycolysis regulation. That's going to include hexokinase, phosphofructokinase, and pyruvate kinase. Now, hexokinase, this enzyme is the first step of glycolysis. It's taking that glucose and is changing it or moving it to a glucose 6-phosphate. This is how you start glycolysis. It's a very important step. It has a lot of control and is regulated to make sure glucose is only used when it is needed. Now, phosphofructokinase, sorry, I can't pronounce half these things. This is the most important point of glycolysis and glycolysis regulation. It helps decide whether the cell should continue to break down glycolysis or store glycolysis as glycogen in order to store, the ability for energy in the future. We don't always want to use ATP because we don't always need to use ATP. That's why we store it in our liver or store it as glycogen in our body. So when we are ready to work out, it will convert it through the glycogen to the glycolysis pathway, and we'll be able to have energy already in our body without having to resynthesize it like that or eat before we do anything. It helps decide, again, whether the cell should continue or the cell should stop with glycolysis. It is activated when energy is low or inhibited as well. Finally, pyruvate kinase is the enzyme that controls the final step of glycolysis. ATP is produced from pyruvate kinase. It regulates the part of glycolysis that stops when the cell does have enough energy and when it needs to be stored. It will stop it from producing pyruvate and is a catalyst for pyruvate being changed into lactate because when it produces pyruvate, this is a substrate or intermediate process to lactate dehydrogenase, in which it will be converted into lactate to continue to resynthesize that ATP. Hexokinase is inhibited by glucose 6-phosphate. This prevents overprocessing of glucose. Hexokinase is used to make glucose into glucose 6-phosphate. So when we have the glucose 6-phosphate, there is no reason to make more glucose 6-phosphate. You have it. So the glucose would just not be converted at that point. Phosphofructokinase, or PFK1, is activated by AMP, which signals low energy, prompting the need for glycolysis, for ATP resynthesis, and for energy. This promotes glycolysis when it is activated, but when it is not activated, it does not promote glycolysis, and that process stops. Finally, pyruvate kinase is inhibited by ATP. This is because we won't need ATP or more energy the more pyruvate we have. So if we already have pyruvate kinase is not going to need to go on, or if we already have energy, pyruvate kinase is not going to need to continue the process of creating ATP because we have the energy already stored, or we have the energy ready. It makes sense because when we have enough of something that is used to continue the process of glycolysis, we don't need to create more. We don't need excess. We don't need to over create or over make. That's why it makes sense, because when you have enough, it's like supply and demand. When you have enough, you have enough. It's not in demand.